Okay, now we will see the exemplar problems in the chapter 12 Organic Chemistry, some basic principles and techniques. Okay, before going through it, I will show you some general information. Okay, this is hybridization. When you have a single bond, carbon single bond, you will have the sp3 hybridization. When you have a double bond, that is only one double bond, you will have the sp2 hybridization. When you have a triple bond or two double bonds, triple bond or two double bond, you have a sp hybridization. So in sp hybridization, we have 50% S character and 50% P character. Okay, S50, P50. So here in sp2, we have one S and two P's. So there are three parts, one S and two P's, S plus P plus P. So one third of is S character, 33%, and P character is 66% because two P's are there. In sp3, we have one S and three P's. So 25 plus 25 plus. So S character is 25%, P character is 75%. As the S character is more, then electronegativity is more. So among these three hybridization, sp3, sp2, sp will have the higher electronegativity. sp hybridization. The examples of this sp3, sp shown. So this compound, we have a sp here because of triple bond. This also sp, sp, sp. Okay. Now in this compound, if you take, see here only single bond, so sp3 hybridization, sp3 hybridization. So this we have a triple bond, this triple bond, so this is sp hybridization. Here also single bond, sp3 hybridization. Now if you look at this example, we have a carbon with two double bonds, this, so this is also sp. So sp hybridization is a triple bond or two double bonds. So this is sp hybridization, and here we have a one double bond, so sp2, this is also sp2. Okay, here you see this is sp2, 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 sp2. Okay, the more S character, then more electronegativity. Okay. Now, if you take this carb cations, carbocation, so cation is the one with carbon with a positive charge. So here we have three methyl groups attached to it. The methyl groups are electron donating groups. Okay. There is a positive charge, and this is donating the electron, that is negative charge. So the positive negative will cancel out each other. This will become stable. So here only two methyl groups are there. So this is three ethyl group more stable than the two ethyl group. So sorry, two methyl groups. Here only one methyl group is there. So this is more stable than this, and this is more stable than this. Look at these arrows I used. This stability is greater than this, and greater this is greater than this. Okay. When a carbon is attached to three carbon, then there is a tertiary carbocation. This is secondary, two carbons attached. This is primary. Okay. This is carbocation. This is positive charge. But look at the carbanion, where we have a negative charge on the carbon atom. So already negative charge is there, and this methyl groups is donating electrons. So that is also a negative. Then that will destabilize this compound. Okay. Look at this arrow. If this is less than, and here it is greater than. So this stability is less than this, and this is less because here less methyl group is there. So so less electron is pumped in, and this is more stable than this. So this is more stable than all the compounds. Okay, look at the arrows here. This is carb cation stability and carb anion stability. Okay, this is less stable than this, and this is less stable than this, and this is less stable than this. Is more stable here, whereas in this case this is more stable. Okay. Okay. Now we will see the multiple choice questions. Which of the following is correct the IUPAC name? So you have to see the IUPAC rules here. So here what this rule says, lower number is given to the one coming first in the alphabetical list if more than one functional group. Here see ethyl, methyl are present. So ethyl will be given the lower number. Here ethyl should be given the if two substitutes are found in the equivalent position, the lower number is given to the one coming first in the alphabetical order. Okay, this one rule. And here see the names of the alveol group attached to the branch and prefixed to the parent position, they are listed in the alphabetical order. So these two rules you have to use this rule number 3 here, rule number 5 here, and again rule number 3. So these three are wrong. So this is the correct answer. Now the IEPAC name for this. Okay, that is 11. So here the order of decreasing priority if more n in case of polyfunctional compound. One of the functional group is chosen as principal functional group. Okay, you can go through this. The order, this is the order. Carboxylic acid is have the higher order than the other. So using this rule, you have to name this compound. Okay, and this is the correct answer. IUPAC name for this is 14. See, there is a similar compound is given with chlorine, methyl, and this NO2 group. So they renamed, they named this like this. So you have to use this same procedure to name this compound. Okay. So based on this, and this is the correct one. 1 chloro, 4 methyl, 2 nitrobenzene. Okay. Electronegativity of carbon atoms depends on the state of hybridization. As I already showed you in the beginning, the more S character, then more electronegativity. In which of the following compound the carbon marked with asterisk is most electronegative? See, here this is sp3, okay? Sp3 and this is sp2, because here we have only single bond in the carbon, here we have a double bond for this sp2, here we have triple bond for this as carbon sp2. So this is because this is triple bond sp character and more s character, that is 50% s characterizer, so this is more electronegative. In which of the following functional group isomerism is not possible? So here this alkyl halides only one way you can attach the halogen to the carbon atom. Okay, same molecular formula but different functional group is isomers, functional group isomerism. Okay, these you can read the fragrance of flowers is due to the presence of some steel volatile organic. Okay, these are generally insoluble in water. So you can go through this steam distillation method. This is the answer. Okay, in the book page 26. So this is the answer for that question. Okay, you can go through what is steam distillation. During the hearing of the court case, a judge suspected that some changes in the document has been carried out. He asked the forensic department to check the ink used at different places according to which technique. Thin layer chromatography. This also you can go through, that is in the book. What is thin layer chromatography and how to what are the applications of it. This is the thin layer chromatography. Okay. The principle involved in paper chromatography is 29. This is the partition. This is the answer. 29. See here, paper chromatography is a type of partition chromatography. Okay. What is the correct order of decreasing stability of the cation? See, this is important. This is a cation they are asking. Okay, so decreasing stability, the most stable should come first. So here, this is the electron donating group. So this is a stable compound. But here, this is also stable. But here there is a resonance is there. This is C oxygen double bond will produce lesser resonance structure. The resonance is more stable than the induction. Okay. Here resonance is there. Here resonance is not possible, but negative induction is there. Negative induction means this oxygen here will try to pull electrons towards it. So from here it will pull the electrons towards it. Okay. So then this it will become more positive and unstable. Okay. This is so in terms of stability, this is more stable due to resonance. Next this structure and the last is this. So this is the correct answer. Resonance stability is greater than the induction stability. The correct IUPAC name for this. So here when you are numbering the longest chain as per the IUPAC rule, you have to see which one is the longest. So the numbering is a trick here. So here see how it is numbered. 1, 2, 3, 4, 5, 6. Like that you have to number. Not on the here. So you have to number like this. So look at the longest chain number. Okay, this is how you have to number it. Okay, based on that, this is the correct answer. Button. Which of the following compounds the carbon marked with the asterisk is expected to have greater positive charge? See, the electronegativity, this is the electronegativity of chlorine 3 and bromine is 2.8. Chlorine is more electronegative than the bromine. So here, so the chlorine will pull electron towards it. So it will get a positive charge because of the chlorine is present here. Here also chlorine is present, but some of them positive charge will be supplied by this. So this will have a less charge than this. This will have the more positive charge, okay, because more En pulls electron towards it. So here this is the electron donating group, so it will not pull the electron here. So this is the answer, first one. Ionic species are stabilized by dispersal of charges. Which of the following carboxylate ion is the most stable? See here, we have two fluorine. Two more fluorine is the most electronegative, and two fluorine. There is also resonance here. So the resonance will have stability. This pulling electron. This is also will produce dispersal of charge. This will stabilize. Okay. So here. Uh, this will have resonance as well as inductive because of the electronegative, and this will have more stable. Here only one fluorine atom is there. Here we have two fluorine atoms. Electrophil addition reactions proceed in two steps. The first steps involve the addition of the electrophile. Name the type of the intermediate. See here, when you add this, when the electrophile reaction, so this will break attacks on the double bond, this double bond will break, so this will form the positive charge, okay, that is cation, carbocation, okay. But as already showed you, see, the secondary carbocation is more stable than the primary carbocation. And the starting of this lecture I showed you. So one of these, that is carb cation, first primary or secondary should be the answer. So secondary, because the secondary is more stable. Secondary carbocation is more stable than the primary one. Covalent bond can undergo fission in two different ways. The correct representation here, when electron is passed to the atom, that atom will have a negative charge and the donator will have positive. So here you see this electron is passed, so this should be negative here. This is wrong because the positive is mentioned here. Electron, bromine is taking electron, this is negative, but the other things here you see this bromine positive they mentioned. This is wrong. So this one is the correct answer. So here in 18, so they even the similar problem you can go through it. See here this arrow, which one is getting positive and which one is getting negative. Okay, addition of electron will get a negative charge. Addition of HCl to alkyl position in the first step. So here also you see this double bond will attack this hydrogen. Okay, will join. This is the correct representation. Which of the following compound contain all carbon in the same hybridization states? Here all are sp triple bond. So here we have here sp and this is sp3. They are different ones. Here this is two double bond is there. So this is sp and this and all sp2. Okay. So they are asking contain the same hybridization state. These two all sp and all sp2. These two are the correct answer. In which of the following representation given below, the spatial arrangement of the group are different from the given structure A. See here, the single line means the same plane. This is towards the observer. This is the away from the observer. Okay, this is towards this arrow pointing towards the coordinate. This is away from the observer. So if you take that rule, then all are different only. So these all are different only. The second also different. Okay, and you will have to refer to the other resources because these all are different only. Here you see CH3 and B are in the same plane. That is the not same as EA. Electrophiles are the electron-seeking species, that is electron lovers. Which of the following group contain only electrophiles? So here, if you see here, only electrophiles are on the water is a nucleophile. So here, electrophile means negative charge, that is only electrophiles. Okay. So here, electron loving. So the here positive charge here, this will love the electron. Here sulfur will get a positive charge because of the oxygen electronegativity. Here aluminum will get positive charge. So these are electrophiles here. These are all positive charge. These are all electrophiles. But this is because negative charge here. This is a nucleophile. Okay. So this is they are asking what is only electrophiles. So these two are the correct answer. Consider the following four common answering questions. Okay. Which of the following for position isomers? Okay. What is a position isomer? 15. When two or more compounds differ in the position of the functional group with the same molecular formula, but the function position of the functional group will be different. Okay. So based on that, we have a 2 and 3. 2 same functional group but the position are different, this one and this one. 20. Which of the following pairs are not functional group isomers? They are asking, they are not functional group. Okay. So 2 and 3 are the same functional group. So they are 1 and 4 also same functional group. 2 and 4. 2 and 4, these two are in the same functional group. So they are not in the functional group isomers. Nucleophile is a species that should have nucleophile which attract nucleus, that is which loves nucleus. Nucleus is a positively charged, so the species which loves nucleus should have electron to donate and negative charge. Hyperconjugation involves the delocalization of electrons of carbon hydrogen sigma bond of an alkyl group directly attached to the atom in the unsaturated system. 22. Okay, so you can go through what is hyperconjugation here. So it involves delocalization of all those things. Okay. Okay, short answer type. Okay, consider these structures 1 to 7 and answer the question 23 to 26. Okay. Um, 1 to 4, the OH group. These are alcohol groups. And 5 to 7, they are ethers. Okay. Which of the above components form pair of metamers? Metamer, what are metamers? They are the different alkyl chain on either side of the functional group. 60. It arises due to the different alkyl chains on either side of the functional group of the molecule. Okay, these metamers. So here 5 and 6. See these 5 and 6, we have the different ethyl groups, different alkyl group on either side of this O. Okay, here also. Similarly 6 and 7, 6 and 7, 5 and 7. Okay, the molecular formula is C4H10O, same molecular formula, but they have the different structures. Identify the pair of components which are functional group isomers. Okay, they are the functional group isomers. Functional group Functional group isomers have same molecular formula but different functional group. Okay, so here these are the functional group isomers. Same molecule, all are same molecular formula, but they are in this different functional group. This is one same molecular formula. This is also same molecular formula, but they are different functional group. Alcohol, this is O group. Samely the other combinations. Okay. Functional group isomers. Two or more common having same molecular formula but different functional group. Okay. Identify the pair of that represents position isomers. Position isomers. Okay, this is 25. 15. Position isomers. Position isomers when two or more components differ in the position of the functional group. Okay, here see OH is attached to here, here OH is attached here. In the second position, this is first position. So they have the same molecular formula, but the functional group attached in the different places. See 1 and 2. The 1 and 2, here OH is attached here, but OH is attached here. Similarly 3 and 4, 6 and 7. Identify the pair of components that represent chain isomers. This is 15. Chainerism, isomerism, when two or more compounds have a similar molecular formula but different carbon skeletons. In the main chain, they have a different carbon skeleton. See here, these are the examples. Okay, chain is 26. Okay, chain isomers have the same molecular formula but different carbon skeletons. 1 3 1 4 2 3 2 4. 27. For testing halogens in an organic compound with AgNO3 solution, sodium extract. This is the test is acidified with dilute HNO3. What will happen? The student acidifies this extract to dilute sulfuric acid in place of nitric acid. Okay, 27. White precipitate of this compound will be formed. Okay, 27. 30. Okay, we can go through this halogens test. Here they have mentioned what will happen, that white precipitate. What is the hybridization of the each carbon in this compound? So here sp2, because double bond, this carbon has double bond on both sides, so this is sp hybridization. Here also sp2. He explained how the electronegativity of carbon atoms related to the state of the hybridization in the organic compound. 29. Electronegativity increases with increasing S characters. Okay, the sp hybridization will have more electronegativity because it is 50% S characters. The greater the S character of the hybrid orbital, greater the electronegativity. Okay, they have mentioned in the book here in this page. Is to show the polarization of the carbon magnesium bond in the following structure. See here the carbon is more electron than the magnesium. So the magnesium will get positive, partial positive. The carbon will get partial negative. 30. Okay. Electrode carbon is more than the magnesium. It will behave as like this. X we can substitute for any halogen. Compound will have the same molecular formula but different structure are called structural isomers. What type of structural isomerism is shown by this? This is metamers. Okay. Different alkyl group on either side of the functional group. 16. I already showed you what is a metamer is. Which of the following selected chains is the correct to name the given compound according to the IPC? Okay, 32. The 4 chain, the selected chain should have the maximum number of functional group. So this 4 chain, it has this one functional group here as well as this. So we have alcohol and ketone here. In DNA and RNA, nitrogen atom is present in the ring. Can this method be used for the estimation of the nitrogen in this? So 33. DNA, RNA have nitrogen in the heterocyclic rings. Nitrogen present in rings, also groups and nitro groups cannot be removed as ammonia. 33. So you can go through this. This is the method is not applicable for compounds containing nitrogen in nitro and azo groups. If a liquid compound decomposes at the boiling point, Vithi methods can be used to choose for its purification. It is known that compound is stable at high pressure, at the low pressure, steam volatile and insoluble in water. 26. Okay. Steam distillation separates substances which are steam volatile and immiscible with water. Answer the questions 35. The basis of the information given. Stability of the carbocations depending upon the electron releasing inductive effect of the group adjacent to the positively charged carbon atom, involvement of the neighboring groups in the hyperconjugation and resonance. Draw the possible resonance structures for this compound and predict which of the structures are more stable. Give the reason. So these two are the resonance structure. The structure 2 is more stable because every atom has a complete octet. So this has each oxygen, carbon, hydrogen, everything is octet complete. Which of the following ions is more stable? Use resonance to explain your answer. 36. Structure 1 is more stable due to resonance. Okay. So here after resonance, here the charge will be removed and double bond will be formed. No resonance possible in structure 2. In structure 2, there no resonance is possible. This has resonance structure, so this is more stable. Structure of the whatever this compound cation is given below. This is very stable. Some of the salts can be stored for months. Explain the cause of the stability of this cation. Okay, this is due to the resonance. Okay. this first you take the first ring, so you move the double bond. Okay, so now here you will get a positive charge, here double bond will be formed. Then you move this bond here, so the positive charge, you will get a positive charge here. Then move this bond here, you will get a positive charge here. So now I did for the one Benson ring. We can do for the other two Benson ring also. So totally there will be 9 structure. For one Benson ring there are 3 more resonance structures. So since same way we can draw resonance for the these 3 Benson ring 2 and 3, they will get 9 resonance structures. Okay, you can drop for the more. So due to because of that, is more stable. Right structures of the various carbocation that can be obtained from these 2-methyl butene. Arrange the carbocation in the order of increasing stability. Okay, these 4 possible structures, carbocations. Okay, the structure 3 is more stable than 2, than 4. Structure 3 is more stable. Okay, because this can be stabilized with this electron donating group. '39. 3 student they are doing this test. Okay, you can go through this 39. Okay, so this is the reaction they are mentioning. So here you can go details about this test. You can read about details in the book. Name the compound whose line formula given below. So this is the compound. You can go through the book how to convert the line formula into this molecular. Similarly, convert this line formula into the structural formula. Okay, this is the answer. Draw the resonance structure of the following compounds. So you move the double bond, this will get a negative charge. Where you are receiving the electron, so you'll get a negative charge. So this is donating the electron, so here you will get a positive charge. Same way you can see for the other structures also. Identify the most stable species in the following set of ion. Give the reasons. Replacement of hydrogen by bromine increases the positive charge on the carbon atom and destabilizes the species. This is the most unstable. Here they are asking identify the most stable In CCS3, this is most stable. Because of this electronegativity of chlorine is more than the hydrogen. On replacing hydrogen by chlorine, negative charge on the carbon atom is reduced and the species gets stabilized. Here, the replacement of hydrogen by bromine increases the positive charge on the carbon atom and destabilizes the species. Q44 give 3 points of difference between the inductive effect and the resonance effect. See, inductive effect, single bonds, that is use of sigma electrons. Resonance, double bond, 5 electrons it's using. Inductive effect is become negligible after 3 carbon atoms. But this resonance all along the length of the conjugated system. Slightly displacement of electrons. This is inductive effect. Resonance is effect, complete transfer of electrons. Which of the following compounds will not exist as the resonance hybrid? Give the reason. 45. CH3OH. So any possible contributing structures will have the charge separation and incomplete octet of the electron atoms. Okay. So answer is this. This won't have the resonance. Why does SO3 acts as the electrophile? Electrophile means that is the electron loving. Here sulfur will have partial positive charge. So it needs electrons. This gets positive charge because of the oxygen electron activity which pulls electrons from the sulfur. 46. See here. So because this oxygen pulls electron, this will get a positive charge. So it needs electron. That is why electrophile. The highly electronegative oxygen atoms are attached to the sulfur atom. It makes sulfur atoms electron deficient. So due to resonance also, sulfur acquires positive charge. Both of these factors made SO3 as the electrophile, that is electron loving. Sulfur needs electron. Resonance structures of the propanol given below. Which of the structures are more stable? Give the reason. So this structure is more stable than this because this is octet complete. There is no charge separation here. 47. Uh, this first is more stable than the second. By mistake, the alcohol boiling point this given was mixed with the other with boiling point this. Suggest a suitable method to separate these two compounds. Explain the reason for your choice. Simple distillation can be used because two components boiling point differ by more than 20 degree. Okay, this is the reason. More than 20 degrees, so you can use simple distillation. Which of these two structures A and B are given below are more stable by resonance? So 49. This is the resonance structure. So here the structure B is more stabilized as does not involve charge separation. So there is no new charge formed in any of the atoms. This charge is only moving. So here, but there is a charge separation here. So this is structure 2 is structure B is more stable than 1. Column 1, column 2. Two solids which have different solubilities in solvent which do not undergo the reaction dissolve on it. E. Decrystallization. Liquid that decomposes at boiling point. Okay. Distillation under reduced pressure. Steam volatile liquid, steam distillation. Two liquids which have the boiling point close to each other. So is fractional distillation we have to use. Two liquids with large difference in boiling points. Okay, then you can use it simple distillation, more than 20-degree difference. Match column 1. Carbocation. sp3 hybridized carbon with the NTP orbital. Nucleophile. Nucleophile means nucleus is actually positive. So nucleophile means nucleus lover. So it can supply pair of electrons. Hyperconjugation. Conjugation of electrons of CH sigma bond. Sigma bond with the empty p orbital present in the adjacent positive charged carbon. Isomers. These two are isomers. sp hybridization. Ethane. Okay. sp hybridization. Electrophile. The species that receive pair of electron. Electrophile means electron level. So it can receive the electron. This method is C for nitrogen gas. Casual method E. Okay, ammonium sulfate. Method A. AgNO3. Chromatography. Silica gel. Homology is free radicals. Free radical. This is structure trigonal planar carbocation. That is also trigonal planar. Carbanion pyramidal. Match the given ABD. This structure A stable due to resonance. Okay, here pair of electrons are there for resonance. B destabilized due to inductive effect. Okay. D a secondary carbocation. Okay. Okay. B is replaced due to resonance because this will pull the fluorine will pull the electrons, so more positive charge will be formed here. So destabilized due to inductive effect. So here the already negative charge, the electron it will supply more electrons, these methyl groups. So that are more charge will negative charge will be formed here. Destabilized due to inductive effect. CD. Stabilized by hyperconjugation is secondary carbocation. Yeah. Two carbons attached to the single carbon. Simple distillation can help in separate a mixture of propane on all boiling point is because more than 20-degree liquids in different more than degree steam distillation. Okay, so both A is correct and reason also is the correct. The energy of the resonance is equal to the average of the energies of the all canonical forms. Resonance hybrid cannot be presented in a single structure. Okay, this is correct. Our reason is correct, but A is not correct. Assertion is not correct. Energy of the resonance hybrid is equal to average energy. That is not correct. Pen 1 and pen 2 all this. Position isomers differ in position of functional group. What is substituent? Okay. Both A and R correct. R is the correct explanation of the A. All carbon atoms in R sp3, this is wrong. Wrong. In this molecule, all the carbon atoms are attached to each other by double bond. No, both are wrong. R is correct. Carbon atom, in this molecule, all carbon atoms, okay, carbon to carbon atom, each other by double, okay, that is correct. A is not correct, but R is correct. Sulfur present in the organic form can be estimated quantitatively by Gauss method. Sulfur is separated easily from other compounds. Okay, both are not correct. Both are not correct. Component of the mixture of the red and blue ink can be separated distributing the components between the stationary and the mobile phases in paper chromatography. Okay, the colored compound like inks migrate at different rates because of the paper selection. Okay, both A and reason are correct. What is meant by hybridization? In this compound contains sp or sp3 is answer. Okay, here this is the carbon, here this is sp hybridized, here sp2, this sp2. Central carbon atom is sp hybridized and its two unhybridized p orbitals are perpendicular to each other. The p orbital in one plane overlap with the p orbital of the left terminal carbon atom, and the p orbital in the other plane overlaps the p right terminal carbon atom. This position of the two terminal carbon atoms and the hydrogen atoms attached to them in the plane perpendicular to each other. Due to this, the hydrogen atoms attached to the terminal atom are present in different planes. So this is sp and all this terminal is sp2. These things you can go through. These long answer type are given in the book. Two liquids are separated by the method of the fractional distillation. So that is also you can go through the book. Okay. So everything is given in the book. You have to practice yourself.